percentage is linear algebra?
Ooh. How much does the head sign of a coin depend on the tail side of a coin?
100%.
Really? When I think about, you know what? I wasn't planning on doing this, and I got to be careful because I need to shut up. Say, shut up, Anderson. Let's go back to, okay, so do you see the math learning skills activity page? The gentleman that told me I should buy these pens, his name was Peter. What a beautiful contribution to the world Peter made by making me buy these on Amazon. He also was an applied math major, and at one point during our time together, he's like, you know what, I just don't think I'm going to do applied math anymore. I don't know why I would ever work with it. And I said to myself, that's a sin. This guy's a bright guy, and we are turning him away. And so I spent something like 18 hours putting together an answer to his question. And then I provide it for free online. If I knew how to use Photoshop, I would definitely Photoshop this into a poster. But I don't know how to use Photoshop, and I don't really care to learn because I have other problems that I'm working on. Okay. So this is what I call the diagram of applied math. Brought to you by yours truly. God bless my wife. She has not left me yet. So I think about if I can help it, she will never leave me, but that's her choice. And I am strange, so. I think about 3 pillars of applied math. So the first pillar of applied math is differential calculus. The second pillar of applied math is linear algebra, and the third pillar of applied math is differential equations. We generally teach you all of this, and the sad truth is, at the end of calculus, you know the only thing that you learned that was useful? The chunk, the little prime. The whole reason you go through calculus, literally, is so that you understand what a derivative looks like and what it means. The sad truth about the world around us is most differential equations that model something of interest are not solvable using analytic techniques that you learned in calculus. Right? So the whole point of calculus is to give you the fundamentals of notation to allow you to describe change. And then eventually, with your science classes, if you combine, with our powers combined, we are partial differential equations that describe the world. Okay, but the funny thing about partial differential equations is they're really, really, really hard. Like good partial differential equations, nobody on Earth can solve them. Navier-Stokes is a Clay $1 million prize. Nobody solved it. So do you know what we do? Well, the first thing we do is we get down on our knees and we pray. We say, please, please, please solve it. And then nothing happens. And then we think to ourselves, well, that didn't work. What's the next best option? Discretize. So we chop them up into little pieces. We linearly approximate. The moment we linear approximate, we now go from a nonlinear regime into a linear regime. You know what type of analysis allows you to solve linear problems? Linear algebra. You know what's really cool about finite computation machines?
They're good.
They're optimized to solve linear problems. We've had 60 years of development. And so it's weird to say which one is more important. This sets the theoretical foundations to allow you to state these things. And then linear algebra I like to call the workhorse of applied mathematics, because in linear algebra, you actually can solve problems that you cannot solve analytically. So let me think about it this way. Let's imagine that the design of some real world problem is lifting a 1,000-pound rock. Okay. So theoretically, if there's a 1,000-pound rock right here, theoretically, can I solve that problem? Yes. What would I have to do? Okay, that's calculus. Theoretically, I know how to solve that problem. That's calculus, right? Okay, realistically, is it as easy as the theory? No. No. Linear algebra is the thing that actually picks the freaking rock up and moves it where you want it, in my opinion. Now, nonlinear algebra would be like, no, it's the opposite. It's the opposite, right? But, yeah. So that's an answer to the question. That's available for you on the applied math website, right?